Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So today we'll be looking at chemical bonding, specifically ionic bonding. So our lesson objectives for today is candidates should be able to define ionic bonding as the electrostatic attraction between oppositely charged ions, positively charged cations, and negatively charged anions, and also describe ionic bonding, including the examples of sodium chloride, magnesium oxide, and calcium fluoride using the dot and cross diagram. And then state the properties of ionic compounds, which are compounds that are formed as a result of ionic bonding. So please, I want us to listen attentively and get the best out of today's lecture. So we are looking at chemical bonding, and we say compounds are formed when two or more elements are chemically combined together. Compounds are substances that are formed when two or more elements are chemically combined together. It can be metals, it can be non-metals, it can be both. So when they combine, they form forces of attraction called bonds. Then the one we'll be talking about is forces within, which are called intramolecular forces or intraatomic bonds. So we'll be looking at ionic bonding, covalent bonding, metallic bonding. But for today, we are going to concentrate on ionic bonding, which is an example of what? An intraatomic bonds or intramolecular forces, which are forces within atoms. So we'll be looking at ionic bonding today. So now we're looking at ionic bonding. So what is an ionic bond? It's all about the electrostatic force of attraction between oppositely charged ions, between positively charged ions and negatively charged ions. So that force that exists between oppositely charged ion, negative and positively charged ions is what we call what? An ionic bond. Now, it involves a metal and a non-metal. Metals ionizes by losing electrons. When they lose electrons, they become positively charged. So they form positively charged ions. And non-metal ionize by gaining electron. And when they gain electron, they form a negatively charged ion. The essence of losing and gaining electron is for them to attain their noble gas configuration. So what happens in ionic bonding? It involves a metal and a non-metal, where the metal is the electron donor and the non-metal is the electron acceptor. So there's a transfer of electron from the metal to the non-metal. So to form positive and negatively charged ions. So the electrostatic force of attraction between the positively charged ion and the negatively charged ion is what we call what? Ionic bonding. So it's as simple as what? A, B, C. So we want to use dot and cross diagram to represent the formation of ionic compounds. Ionic compounds are formed as a result of the electrostatic force of attraction between the positively charged metallic ion and the negatively charged non-metallic ion, where the metal is the electron donor and the non-metal is the electron acceptor. So we are looking at sodium chloride as a typical example. This is sodium chloride, which is what? NaCl, which is NaCl. So we want to draw the electronic configuration using dot and cross diagram. So this is sodium, which is the metal. We are going to show only the outer electrons, which is 281. It has one electron in the outermost shell, plus chlorine. Chlorine is 17, so it has 7 electrons in the outermost shell. So we're using the dot and cross diagram to represent it. So what happened is that what? So there's a transfer of electron from sodium to what? Chlorine. So this is 287. So there's a transfer of electron from sodium to chlorine. So you form positively charged sodium ion, which is Na plus. Then you have your what? Chlorine, which is negatively charged. 1, 2, 3, 4, 5, 6, 7. Negatively charged chloride ion, which is Cl minus. So this is 2,8, and this is what? 2,8,8. So this is sodium, which is sodium positively charged sodium ion, and negatively charged chloride ion. So it's as simple as A, B, C. So we're going to look at other examples of ionic compounds and using dot and cross diagram to demonstrate the formation of the ionic compounds. So it's as simple as A, B, C. So still a representation of ionic compounds using the dot and cross diagram. So this is magnesium oxide. We want to look at the representation of magnesium oxide with the help of what? Use of what? Dot and cross diagram. So this is magnesium. The atomic number of magnesium is 12, so it is 282. So magnesium have 2 electrons in the outermost shell. So we are using cross for magnesium. Then we are going to use dot for oxygen. Oxygen has 6 electrons in the outermost shell too. 2, 1, 2, 3, 4, then 5, 5, and 6. So in bonding, this one sodium, so oxygen needs 2 electrons to complete it. Oxygen, so this is a transfer of electron from this to this. So we're going to have from magnesium to what? Oxygen. So we're going to have positively charged magnesium ion because there's loss of electron, and we're going to have negatively charged what? And oxide ion, which is 1, 2, 3, 4, 5, 6, 2 minus. So this is 2, 8, and this is what? 2, 8, which is 2, 6. So Mg2 plus O2 minus. So it's an ionic compound which is formed as a result of the electrostatic force of attraction between the positively charged magnesium ion and the negatively charged what? Oxide ion. So it has to do with the transfer of electron from the metal to what? To the non-metal. So it's as simple as what? ABC. So we're still on dot and cross diagram for calcium fluoride. Calcium fluoride, which is an ionic compound. Calcium fluoride is CaF2. So we want to represent its formation using the dot and cross diagram. The metal is calcium, while the non-metal is fluorine. So calcium is the electron donor, while fluorine is the what? Electron acceptor. So we're going to use the outer electron. So we are using cross for calcium, then we are using dot for fluorine. So fluorine has 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7. So we need 2 atoms of fluorine, to transfer electrons from calcium to fluorine. Since 1 atom of fluorine needs 1 electron to complete its octet state, and in calcium we have 2 electrons in the outermost shell. So we need 2 atoms of fluorine to satisfy 1 atom of calcium, because 1 atom of calcium have to transfer 2 electrons, has 2 electrons in this outermost shell to transfer. So we have 1, 2, 3, 4, 5, 6, 7. So there will be a transfer of electrons from calcium to fluorine. Also transfer of another electrons from calcium to fluorine. So we're going to have, this is 2, 8, 8, 2, and this is 2, 7. So we're going to have calcium ion, which is Ca2 plus. Then we're going to have the fluoride ion, which is the electron acceptor. So we have 1, 2, 3, 4. Though we're using dot and cross, 5, 6, 7. Then we'll have another 1, 2, 3, 4, 5, 6, 7, 8. So as you can see, so we'll have, this is 2, 8, 8, while this is 2, 8. So we'll have calcium ion and 2 moles of fluoride ion. So it is formed as a result of electrostatic force of attraction between the positively charged calcium ion and the negatively charged what? Fluoride ion. So that is how ionic bonds are formed using the dot and cross diagram, where it involves the transfer of electron from the metal to the non-metal, where the metal is the electron donor and the non-metal is the electron what? Acceptor. So that forces of attraction, that electrostatic force of attraction, so to call what? Ionic bond. So it's as simple as ABC. You can attempt as many questions as possible. You can draw the dot and cross diagram of other ionic compounds. So it's as simple as ABC. Please attempt as many questions as possible, and feel free to reach out to me if you encounter any difficulty with the use of the dot and cross diagram. So I want to look at the properties of ionic compounds. Typical examples of ionic compounds around us, the salt we use in cooking in the kitchen, baking powder, they are solid at room temperature. Yes, ionic compounds are solid at room temperature. Like the salt before us, baking powder, and other ionic compounds that is common around us, they are usually solid at room temperature. So they have very high melting point and high boiling point. And this is as a result of the electrostatic force of attraction between the oppositely charged ions that is between the positively charged metallic ion and the negatively charged non-metallic ion. So they have very high melting point and high boiling. Another purpose of ionic compounds is that they conduct electricity in solution or in molten state. They don't conduct electricity when they are solid. This is because the ions cannot move. The ions are not free to move. So they are locked in place by the strong electrostatic forces of attraction. So they only conduct electricity when they are melted or dissolved in water. So the ions are free to move and they carry charges. So they can move from one point to what another. So ionic compounds in general, they are electrolytes. They conduct electricity in solution or in molten state. You know, any substance that conducts electricity when in solution or molten state, where is said to be what an electrolyte. So they are electrolytes. That is, they conduct electricity in solution or in molten state. So another property of ionic compounds is that they are soluble in polar solvent. They are soluble in water and insoluble in non-polar solvent. They are insoluble in organic solvent. So example of a polar solvent is water. Water is a polar molecule. A polar molecule is a molecule that have a dipole. So they have a partially positive and a partially negative charge. And sodium chloride, for example, is an ionic compound. It consists of an aggregate of positive and negatively charged ions. So they are soluble in water. They can dissolve in water. A typical example is the salt you use in the kitchen. It dissolves in water. Your baking powder, they are all ionic compounds and they are soluble in water as a result of the electrostatic force of attraction between the positively charged metallic and the negatively charged non-metallic ion. And water being a universal solvent, it's a polar solvent. It has a dipole, which is a partially positive and a partially negative charge. So there is ease for solubility in water. So it's as simple as ABC. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, share, like, and feel free to reach out to me if you encounter any difficulty. So we'll just look at ionic bonding and ionic compounds. We'll just look at the properties of ionic compounds, then the use of dot and cross diagram to represent, the formation of ionic compounds. So it's as simple as ABC. So please reach out to me if you encounter any difficulty. Subscribe to my YouTube channel. I'm always there for you. Feel free to reach out to me. I'm Mr. Joe, your chemistry teacher. Mr. Joe, your chemistry teacher.